Hello. Hello everyone. How are you?
Fine, sir. How are you, sir?
Yeah, good. So today we will discuss about that electric charge concept, है ना? Electric field also, and then I will give you the questions from the thing as you can start solving. Okay, after today's class,
Okay, sir.
right? Okay, just let's wait for a few minutes. Okay.
Okay, sir.
What happened? Not yet. Only Ramcharan you joined. Location. Others has not yet joined. Hello, Mrinal. Right. Let's wait for just one more minute and then we will start. Okay. Right. Everyone here. Let's start now. Okay. Okay. So last class, what we discussed about the Coulomb's law, isn't it? Tell me, last class we discussed about the Coulomb's law, and we also discussed about the principle of superposition, where we have calculated what is going to be the force on a particle if more than two particles are applying force on it, isn't it? So that is the one more thing we have discussed in the yesterday's class. Let's continue from there. Okay. Yeah. So let's take an example and then we'll continue with the next part. In this example, what is given to us? Okay. In the question, it is given to us that at the corner of an equilateral triangle, okay, 3 point charges are kept. Okay, Q, Q, and Q. Okay. Now, the next thing they are asking, this is the centroid of the equilateral triangle. Okay. What is this point? This point is the centroid of the triangle. Okay. So they are asking what charge we should keep it on the centroid so that net force acting on the corner charge particle or vertex charge particle should be zero. Please tell me, do you understand the question?
Yes, sir.
So the question says that at the three vertex of an equilateral triangle, 3 point charges are kept, right? So what should be the fourth charge? Means how much should be its value? And another thing, what should be the nature of that fourth charge so that net force acting on the corner particle should be zero? Understand the question? Please tell me. Find the magnitude and nature. Okay, both thing we have to find out. Find the magnitude and nature. Should I keep the positive charge there? Magnitude and nature of charge at the centroid. Okay, at the centroid to have net force on the net force on vertex charges as zero. Net force on vertex charge as what? As zero. Understood? And when a particle experiences net force as zero, do we call some other thing also? Can you tell me what do we call? If a particle is experiencing net force as zero, what do we call?
Sir,
Please tell me. Yeah, please tell me what is the name of that condition? If net force acting on a charged particle is zero, or any particle, if it is experiencing net force as zero, it is also called as equilibrium condition, right? So the same question can be also asked it in such a way that find the magnitude and nature of charge at the centroid to have the corner charge particle in the equilibrium. So please tell me what we should do it here. Should I assume the charge at the centroid is something Q,
yes,
right? Which I have to calculate it. Now look at any corner particle, okay? Tell me, I'm going to look at this corner. So this corner particle, is it going to experience the three forces now? One will be because of what? This corner particle repulsive force, let's call it F. Due to other corner particle that will be also repulsive, that is going to be F, isn't it? And these two forces are going to be at what angle? Tell me. It's an equilateral triangle, so can I
60
say these
degrees.
two forces are going to be at 60 degree, right? So can I say these two forces resultant will come and that must be balanced by the third force?
So it should be a negative charge.
Please. Yes. So that means the third force must apply what kind of force? So the third force, third
Attractive
charge
force.
particle must be applying the attractive force. Understood? Let's call this as the F dash. That means resultant of F and F should be balanced by what? the f dash. Is that clear?
Yes, sir.
So please tell me, what is the resultant of f and f going to come? So can I say this f is
F3.
going to be
F
k,
root.
yeah, f root 3. This is k q1 q2 by a square, and this force is also same, k q1 q2 by a square. So f and f resultant, if I calculate it, can I directly write it? It is going to be root 3f.
Yes, sir.
Please tell me how it will come. Just vector we are using, है ना? f1 square plus f2 square plus 2f1 f2 cos theta. Okay,
Cos
na?
60. Yes.
And here the cos theta is going to be angle between the
60.
vector, which is 60 degree we have. Okay, so can we use it here? F square plus f square 2ff cos 60. So we got it as what? Root 3 f. That means we can write it root 3 k q1
K square
q2
by S.
by a square. Now we have to balance that force with what? F dash. So can you tell me how much is the F dash?
F dash root 3 K square by.
Yes. And if I try to write it with the help of the charge particle, what I should write it? The F dash value?
K.
Should we write it K
K
capital
capital
Q
Q.
small
Small q.
divided by? Now tell me what I should write it next.
Uh, Distance between, it will be root 3 by 4. The distance between.
Please tell me, all of you, what is the distance between vertex and centroid? This is the centroid. Okay, this is the centroid. So distance between vertex and centroid in an equilateral triangle, what is that?
Root 3 by 4.
All of you,
Root
please tell
3
me.
by
Root 3a by 2.
root 3.
Root
A by
3
2.
a by 2. That is a by root 3,
Okay, okay, yeah, sir.
right? Distance between
By
vertex
root 3.
and centroid in equilateral triangle is a by root 3. Is that clear? Now let's compare it. We already know the nature of charge, na? This should be what kind of charge? This should be a negative charge. How do
Negative
we know that?
charge.
Because it should create an attractive force to balance the two repulsive forces, isn't it? So nature is already known. Now I just need to find out the magnitude. So to find out the magnitude, should I compare it? Root 3k q square by a square. Should that be equal to k capital Q small q by a square into 3? Can I write it? Right now, root 3 square. We have simplified it. Now just check it. If you cancel out, k get cancel out, q get cancel out, and a square.
Q by root 3.
Right? Q we have root 3 capital Q by 3. So that means it is coming how much?
Q by root
1 by root 3 into Q.
Q.
So the magnitude wise, this should be what? Capital Q by root 3. And nature should be what?
Negative charge.
It should be a negative charge. Is that clear? So that is another question based on what? The electrostatic force using the Coulomb's law and equilibrium condition from the Newton's law of motion. Is that clear?
Yes, sir.
All of you clear about this one? Please tell me.
Yes, sir.
Yes, sir.
Okay. So now if we are clear about the equilibrium, let me discuss one more example. In this example, what is given to us? In this example given, from the support, two strings are there, and these two strings are having what? Two charge particle. Their masses are same and their charges are also what? Equal. Understood? These two particle has same mass and the same charge. Okay. So can they stay together, or because of the repulsion they will be making some angle theta with the vertical? Please tell me.
Yes, sir. There will be some.
They will be making some angle theta with the vertical. Is that clear? So now they are asking that what should be this angle theta? Understood the question? And as per the question, the length of a string is given to us. Length of both the string is given as what? L. Length of both the string is given as what? L. So now they are asking what should be the angle theta made by these charged particle, or angle theta made by made by these particles with the vertical, or angle made by string with the vertical. Please tell me, is it going to be same angle theta or different angle theta? Just first tell me that one. There may be a
Same,
question
sir.
comes like, right,
Same,
it
sir.
should be same,
Charge,
right? Correct, same. Why same? Because if you look at the
charge is same and mass is
forces acting, yeah, if you look at the charge is same, mass is same, right? So if you look at the forces acting on these particles, you will find out the same amount of force acting on both the particle, na? Exactly similar forces are acting, right? So because of that, whatever angle first string will make with the vertical, the same angle the other string is also going to make. Is that clear? So please tell me, what is that angle theta? Understand? And again, the question is given for what purpose? Find angle theta. Okay, find angle theta. Find angle theta made by string with vertical. So please tell me, what should I do it here? Should I start with drawing the forces acting on these
free
bodies?
body diagram. Yes, sir.
Yes, right. So we should start with the free body diagram. Tell me what forces will be there. Can I say one
Tension
tension
force.
will be acting? Tension is always a pulling type of force, na?
Yes, sir.
Tension is always what kind of force? A pulling type
Pull
of force. Next, gravitational force will be there, which is going to be mg.
always down.
And anything else? Please tell me. Is there going to be
Electrostatic
any other?
force.
Yes, electrostatic force. Is that going to be repulsive in nature? Because I
Yes,
have
sir.
taken the
Repulsive.
similar
Same
charges,
Yes, sir.
same
charge.
nature charge. So that is going to be repulsive. That's good. Now, what next I should do it? It is in
Components of free.
equilibrium. So that means, yes. See, vectors now it is being used, isn't it? The component of vector.
Yes, sir.
So if we take the component, can I say that this component is going to be t cos theta, and this component is going to be t sine theta? Now let's write the equation to tell me. Can I say that t sine theta is going to balance the electrostatic force,
Yes, sir.
and t cos theta is going to balance what? The mg.
Gravitation force.
Right. Now, can we put the value of electrostatic force? Is it going to be K, Q1, Q2 by, what is the distance between these two charged particles? Just check it and tell me.
2L sine theta.
How much is the distance? Check it.
2L sine theta.
Yes. Is it the 2L sine theta? Because this is L and this angle is theta. This is a right angle triangle. So can I say that this distance is going to be L sine theta, and the same distance will come this side also. That is also going to be L sine theta. So the distance between these two is going to be how much? L sine
2L
theta, L
sine
sine theta. So we can write it here 2L sine theta square.
whole square.
Right or not? Now we can simplify it. Can we use this equation? Check it here. Or we can divide them, isn't it? If we divide
Dividing will
equation
get
1
tan
and 2,
theta.
yes. If we divide these two equations, what will happen? Tension will get cancel out, isn't it? So let's divide the equation 1 and 2. The sine theta by cos theta becomes tan theta equal to kq square by 4l square sine square
Sine square
theta
theta.
into mg. Is that clear? So now we can bring it one side. Now the values will be given to us in the problem now. Numbers will be given, numerical values will be given. So then we can calculate the value of the theta from this equation. Is that clear?
Yes, sir.
Yes, sir.
Right. So this is what we have it as the question. Clear? Or sometime what will happen in the question, theta will be given, length of a string they can ask you, isn't it? That is also one type of question, isn't it? But the concept what we learn here is, if it is in equilibrium, then the forces acting on the charged particle or any particle which is in equilibrium should experience net force as zero. And to make net force zero, what is the required condition? We should draw the forces free body diagram. We should take the component and then balance the forces. Now, one concept. Do you know about the Lami's theorem?
Kind of, sir.
Yes, sir.
Right. So if three forces are there and the body is in equilibrium, we can also apply the Lami's theorem also. Sometimes it helps us in avoiding the calculation, isn't it? So let me just help you with the Lami's theorem also. Same answer we will get it, okay now? Whether we use the Lami's theorem or we use the component method, we are going to get the same answer. But we should know both the method, isn't it? So now tell me, if I'm going to use the Lami's theorem, what is the requirement? I should know all the angles, isn't it? So can you tell me what is this angle? 90 degree. What is this angle? 90 plus theta. And what is this angle? 180 minus theta, na? Please tell me. Same diagram, I can make it again, na?
Yes, sir.
Just see, same diagram, if we make it one more time, check it. Isn't it? These are the angles we have. Now I don't need the component. I can directly start writing the equation. So what equation we will write it? See, in front of t, what is the angle? 90. So t by sine 90 equal to. In front of mg, what? Look at that. In front of mg, what is the angle? Is that 90 plus theta? And in front of electrostatic force, what is the angle? 180 minus
Minus 3.
theta, right? So we got the equation what? T by sine 90 equal to mg by sine 90 plus theta.
Cos theta.
Cos theta. Positive, na? Because the angle goes
Yes,
to
sir.
the second
Plus
quadrant
cos theta.
and second quadrant sine remains
Sine
plus
positive.
cos theta. F and electrostatic force
Cos
sine
theta.
180 minus theta.
Cos theta.
That is the no sine 80 minus theta.
Sine
Okay.
theta. Sorry, sir. Sine theta.
Whenever it is
Written in 90 degree.
added or subtracted or means 180 degree or 360 degree, isn't it? Then sign doesn't change to cos, it remains as it is. We just need to make sure that which quadrant that angle is there. And in that quadrant, that particular trigonometric ratio is positive or negative. That's what we have to make sure. Clear? Please tell me, is that clear?
Yes, sir.
Now, just two more questions, then all these questions on the what you call electric field calculation, sorry, electric force calculation will be done. Two more example, I'm just going to take it. These two are also very common example. Example says what? Find the ratio of electrostatic force and gravitational force. Okay, gravitational force between two protons. Understood? Kept the same distance. Kept what? Same distance in each case. Same distance in each case. Meaning is what? That you have two protons, okay? You kept some distance apart from each other. So they will be applying electrostatic force on each other. And they will be applying what? The gravitational force also on each other. So we just want to find out what is the ratio of these two forces. Is that clear? Please tell me. Understood the question?
Yes, sir.
So please tell me what is that ratio going to come? Anywhere aware about what is that value?
Sir, K by G into Q square by M square.
Know the we know the value of all these constants now. Please use it.
Okay.
See what is going to be the ratio. Why this ratio is important? Because that is going to give me a very nice situation. Okay, why? See, I want to calculate electrostatic force. So what I will write it K Q1 Q2 by R square. And if we want to write the gravitational force, it will be equal to G M1 M2 by R square. Clear? Are you aware about this one?
Yes, sir.
Please shall बोलिए all of you.
Yes, sir.
Yes, sir.
So this is the magnitude of electrostatic force. This is the magnitude. We can only compare the magnitude because the nature wise they are going to be what? Electrostatic force is going to be repulsive in nature and gravitational force is going to be only attractive. Gravitational force cannot be repulsive. So we can only compare the magnitude of these two forces here, not the direction wise. Okay. So if you take the ratio, this is what asked in the question, take that ratio and you will see an interesting fact that am I getting, if I take the ratio, am I getting kq square by gm square? K is Coulomb's constant whose value is equal to 9 into 10 to the power 9. And Q is the charge of proton which is equal to 1.6 into 10 to the power minus 19 square divided by what is capital G? Universal gravitation constant. What is its value? 6.67 into 10 to the power minus 11. What is the value of universal gravitation constant? Capital G. 6.67 into 10 to the power minus 11 into what is the mass of these proton? The mass of these proton is 1.67 into 10 to the power minus 27 kg. Let's square it. If you square it and calculate the value, exact value is not important, but at least you should have a rough idea that what is the power we are going to get it. Means what is the exponent we are going to get it. Just check it the ratio. Check the ratio once. Is it 1.6 from here and 1.6 from here? I can approximately cancel it out. So do I have 9 divided by 6.67 into 10 to the power 9?
54 minus 38.
10 to the power minus 38, 10 to the power minus, right? So we have it's approximately 9 by 6.67 into denominator we have 65, numerator we have 29 minus 29, right? So 65 minus 29. Is it approximately 10 to the power 40? Right? 65, 30, 65, na? 65 and 29 is there, na? Check it, na? Just once. 65 minus 29. So 35, 36, na? Sorry.
Yes, sir.
So we have 10 to the power 36. You know what is this ratio represent? Does it tell us a very nice idea about that electrostatic force is far, far stronger than the gravitational force? Please tell me. See that electrostatic force is coming 10 to the power 36 times greater than the gravitational force. Right? How much it is coming? 10 to the power 36 times greater than the gravitational force. That's why in the nature, if they ask you, tell me the uh, uh, strength of force, compare the strength of force. The electrostatic force will be what? Much stronger than the gravitational force. But at the same time, if they ask you in the question, tell me the range of force. Range of force. Then gravitational force is a very long range force, but electrostatic force is a very short range force. Please tell me, do you understand these two things what I discussed with you? Please tell me, all of you. There are two things here. One is called strength. One is called strength, and second one is called range. The strength wise, if I say the electrostatic force is far, far greater than the gravitational force. But range wise, gravitational force is far, far greater than the electrostatic force. Understood? Can you tell me why the range wise gravitational force is much, much long range compared to the electrostatic force? Because
even
two
planets
charged
attract
particles.
us. Planets
Yes.
attract other
Gra-
planets.
Yeah, that's a simple reason. Range means what? See, Earth and Sun are far, far away from each other. Earth, Moon, so much distance from each other. But still, they have the influence on each other, na? Means they are applying the force on each other. But charged particle, you just go 10 centimeter from the charged particle and you won't feel any kind of electrostatic force, isn't it? So that's why range-wise, gravitational force has a long range compared to the electrostatic force. But if I keep two charged particles very close to each other, then what will happen? They will have what? A very high amount of electrostatic force between them. Is that clear? Please tell me, is that clear?
Yes, sir.
Then last example, then we will discuss another topic. In this example, what is given? Two charged particle is given to us. One is given plus Q, other one is given 4Q. And they are r distance apart from each other. Now they are asking in the question, where should we keep a third charge particle so that it experiences net force as 0? Please tell me, understand? Where should we keep a third charge particle so that it should experience 0 net force or it should remain in equilibrium? Understand the same thing? Zero net force is also called as equilibrium condition. So sometimes they will use the word it should experience zero net force, or sometimes they can use the word what? It should be in equilibrium. Is that clear?
Sir, between them and near the plus Q.
Between these two charge particles, na?
Between them and near the plus Q charge.
Yeah. Between the two charge particle and near to the plus Q charge, right? Correct? Tell me why? Because if I keep the charge particle here, and does it depend on the nature of charge particle what I'm going to keep it there? Is
No,
that
sir.
distance? No. It will not depend on the nature of charge particle. Either you keep the positive charge there or you keep the negative charge there. Okay? It will be in equilibrium if I locate that point. And you know what is that point called as?
Null point.
Important name is that point is called as the null point. Okay, so all of you are clear that why it should be here, why not somewhere here, or why not somewhere here?
Yes, sir.
Yes, sir.
Clear? So can I just locate that point? If you're not clear, I should explain then. Please tell me.
Explain, sir.
Right. You see, if I take it the particle here, will it be repelled? Let's say I'm taking the positive charge particle here. A plus Q, I kept it here. So can I say, is it going to be repelled by the charge A? Please tell me. Is it going to be repelled by the charge A?
Yes, sir.
And is it going to be repelled by the charge B also?
Yes.
So that means these two charges are, this charge particle is repelled by both the
But
charge
why
particles.
should it be towards A only? Why can't it be towards B?
Sorry, I'm not getting. Tell me one more
The null
time.
point in between A, it is between A and B, no?
Yes.
But why should it be only towards A, like closer to A?
Okay, I will just tell you. Okay, don't worry about that one. Okay. First of all, tell me, it should be between A and B only. That's what let me explain first. Okay, na?
Yes, sir.
Then I will also explain you why it should be near to the point A. Okay. So is it possible to make the force zero if I keep the charge particle here? Two forces are in the same direction. They can never make it to zero, na? Isn't it? Let's keep the charge particle here. Now tell me, will it be repelled by the charge A? Will it be repelled by the other charge B? Again, these two forces cannot make what? Net to be zero. Now, if I keep the charge particle here, right? If I keep the charge particle here, now tell me what will happen. Will it be repelled by the charge A like this? Isn't it? And will it be also repelled by the charge B like this? So now there is a possibility na, that these two forces may become zero, and that gives me net force as zero. Please tell me. Now I want to locate that point. Now I want to locate in the question, where is that point? So let me take that point is x distance from the A. So how much distance from B it will become? R minus x distance from the B it will become, isn't it? From the A, if the point is x distance, then from the B, the point will become what? R minus x distance. Now let's make the net force to be what? Zero. Is that clear? So tell me, what is the force applied by charge A? Can I write it? Force applied by the charge A is going to be K capital Q small q by x square. And that must be balanced by what? Force applied by the charge B. So K 4Q Q by R minus x square. Now simplify it, okay? So K capital Q small q got cancel out. Do we have R minus x by x whole square equal to 4? R minus x by x equal to 2. We have taken the square root. R minus x equal to 2x. We are getting x equal to what? R by 3. Means from the charge A, it should be what distance? R by 3. So from the B charge, what it will become? 2R by 3. Understood? So this is what we got it mathematically, that it should be near to the charge A. Now tell me, let's think logically why I said it will be near to the charge A. See, out of A and B, who is the smaller magnitude charge? Less magnitude charge, tell me. Out of A and B, whose magnitude is small?
A.
A. And you know, force is proportional to charge and force is inversely proportional to distance square. So if charge is small, can I say I should keep distance also small so that a charge which is bigger will need what? A bigger distance to compensate that one. Please tell me, understood?
Yes, sir.
So that's why it should be what? The null point always comes where? It always comes near to the smaller magnitude charge. Is that clear? So one is the mathematical way to understand that we got that point near to the smaller charge R by 3, and another one is the logical way.
Yes, sir.
Force is proportional to charge but inversely proportional to distance square. So if you keep the charge small, you have to keep the distance also small, so that effect of a small charge and a small distance will be nullified by bigger charge at bigger distance away. Clear?
Yes, sir.
So this is what we have. Okay. Now let's go to the. So now will you able to do the questions on electrostatic force calculation, equilibrium calculation? What is the condition needed for equilibrium? Right? Please tell me. All of you will be able to do that.
Yes, sir.
Please tell me. All of you.
Yes,
Yes,
Lokesh,
sir.
Ram
Yes,
Sharan,
sir.
Mrinal, tell me.
Yes, sir.
Right. So let's go to the next part now.
Next is
Okay.
electric field or what, sir?
Yeah, electric field we'll discuss. Before that, let's discuss about the dielectric constant
Pole.
ones. Okay.
Okay, sir.
Dielectric constant or relative permittivity. Like permittivity of a space, we know na epsilon naught. So as the medium changes, what happened? Permittivity also changes, isn't it? Okay. So let's discuss the next part we have is called relative permittivity. Okay. So what is the relative permittivity? Or relative permittivity is also called as dielectric constant. Okay. So let's discuss about first what is relative permittivity or relative permittivity is also called as constant of a medium. So permittivity tells us what? Can you tell me what is the meaning of the permittivity? Please tell me what does it mean by permittivity? Permittivity means what? If a field is applied in a medium, okay, so how much it will polarize the medium? Means how, by what extent the medium particles are going to get polarized. Medium particles are going to get charged. Understood? That is called the permittivity of a medium. Is that clear? Please tell me, is that clear? So that is called the permittivity. So relative permittivity, we represent it like this. Epsilon R. Okay? Relative permittivity represented by what? Epsilon R. Is that clear? So relative permittivity is what?
Sir, your voice is breaking.
Relative permittivity
Hello.
or yeah, please tell me.
Your voice is breaking, sir.
Just check it. It's still 5G only.
Now it's okay. But before it was
Okay.
breaking. Your video was also stuck.
Okay. No. Okay. Now check. Let's check it. I think it's fine now. Okay. So relative permittivity is what? It is the ratio of electrostatic force divided by electrostatic medium. Let's say two particles there. Let's see, two charged particles there. Okay, we kept the two charged particle in the vacuum, so they will apply force on each other. By 4 pi epsilon naught q2 by r, right? If I keep the same two charged particle in the water, they will happen. See, in the vacuum, these are the only two charged particles present. But the moment you keep in the water is what? Made of what? Many particles, isn't it? So presence of these two charged particles, water medium will get polarized. And that will change the force acting on the charged particle. So the ratio of electrostatic force acting on a charged particle in the vacuum to the medium. That ratio is called as what? The relative permittivity, or it is also called as the dielectric constant, the medium. Is that clear? Dielectric constant of the medium means what? Dielectric constant tells about an idea that by what fraction, by what fraction the force on a charged particle is going to be changed if the medium is changed from vacuum to something else. Please tell me. Understood what we just discussed now?
Yes, sir.
So if I write it epsilon r, will it be vacuum? What will be the force? Is the force 1 by 4 pi epsilon naught q1 q2 by r is, and in the medium it is going to be 1 by 4 pi epsilon of that medium. See that medium changes, epsilon changes. Epsilon is not a universal constant. It's a medium dependent constant. Coulomb's constant is not a universal
dependent.
constant. Coulomb's constant is a medium dependent constant, right? So 1 by epsilon by r, simplify it. Q1 Q2 by square got cancel out. Got cancel out. R is equal to epsilon of medium by epsilon naught. What did we get here? Epsilon r, relative permittivity of a medium, is for medium to the permittivity of free space. Okay, so epsilon r, can I write it epsilon of epsilon naught? So if we know the permittivity, if we know permittivity of vacuum, that ratio is called as what? The relative permittivity. And this expression more thing that epsilon of medium can be written as epsilon naught. Clear? So some medium permittivity and vacuum permittivity to always known, na? Vacuum permittivity, so it has most of the time we are using in the question. Epsilon naught to always known to us, 8.85 into 10 to the power minus 12 Coulomb square by, sorry, Coulomb square by, yeah, Newton meter square, na? Right, isn't it? Check it, the unit of epsilon naught, Coulomb square by Newton meter square, na?
Newton meter square.
We have written. Okay. Coulomb square by.
Yes, sir.
You see, the epsilon naught, though it's always fixed. Now, if relative permittivity is given to us in the question, then we can find out the medium permittivity also, isn't it? Relative permittivity given to us, then we can also find out the permittivity of that medium, or medium permittivity is given, then we can find the relative permittivity. Okay, so relative permittivity gives us that by what fraction the force in a medium will change compared to the vacuum, isn't it? Look at the definition of permittivity, relative permittivity, isn't it? Relative permittivity is the ratio of electrostatic force in vacuum to the medium. So if I say there is a medium whose relative permittivity is 5, there is a medium whose relative permittivity is 5. So tell me, in that medium, how many times the force will decrease compared to the vacuum? Please tell me, will it just decrease 5 times? Please tell me. So different medium. Is it audible? Please check it. Am I audible?
Yes, sir.
Right. So now tell me just one more data. Tell me, what is relative permittivity for metal? For metal, what is the relative permittivity or dielectric constant? Can you tell me?
E metal by epsilon.
So how much it will be? Anyone remember? That's infinity. Metal has relative permittivity as what? Infinity. That's why when we will discuss about the properties of conductor, you will see that a conductor has zero electric field inside the conductor. In the electrostatic, the field inside a conductor is what? Zero. Understood? Electrostatic shielding it is also called as, isn't it? If we make a cavity inside a conductor, then in that cavity, the field is going to be what? Zero, which shield it from what? So if you keep any charge particle inside a cavity and in the conductor, what will happen? The force is going to be what? Electrostatic force is going to be what? Zero. That's why it is said, na, if lightning is happening, it's better to stay inside the car rather than what? Outside. Do you understand the reason behind that?
Yes.
Because the field inside the vehicle is going to be what? Zero. But outside, the field can be there, isn't it? Lightning can strike. But here, the metallic car, that will act like what? The shielding to you, shield to you. Okay. Now, next thing we have is called the electric field. Now you know that charge particle apply force on each other, but Coulomb's law only gives us an idea what? The charge between the particles, not between the bodies, no? Tell me. So, if we want the force between bodies, like this pen is there, if I give charge to this pen, how much force this particle is going to experience? So now I cannot directly apply it kq1 q2 by r square, isn't it? So for that, what we need? We need the concept of what? The electric field. Okay. So what is an electric field? Tell me. What is the electric field? So electric field is what? Field generated by?
A charged body.
Yes, it is the field generated by charged body, or you can say that it is the any charged body is there. It will create a what you can say influence in its surrounding, isn't it? It's going to create a field in its surrounding, and any other charged particle, if enters that field region, so that other charged particle is going to experience the electrostatic force, isn't it? What is the gravitational field of Earth? Earth has created its gravitational field, right? The moment any particle enters the Earth gravitational field, the particle will start experiencing the gravitational force. Please tell me. Understood? So, like that, charge particle also create what? The field in its surrounding. Okay. So, what is electric field? It is an influence created by a charge particle, a charge particle in a 3D space, na? In a 3D space, everywhere it will create, na? In a 3D space. And when the other charge particle enter that space, then what happened? The charge particle will start experiencing the electrostatic force. So, if a charge particle enters that space, okay, it starts experiencing the force. Start
Sir, can we do electric field tomorrow? Like it's already 9 now. We'll start freshly
experience.
tomorrow.
Yes, we will. The mathematical part we
And
will do it tomorrow. to
And
start
your voice is also
experiencing the
breaking, that's why.
electrostatic.
Hello.
Okay, let's see that. Okay, no problem. We will continue with the mathematical part of the electrostatic field tomorrow. Okay.
Sir, can you share these notes, today's notes and yesterday's notes, along with the homework?
Yeah. Yes. Now it is there. Okay, na. So I will share it just within 5
The
minutes.
notes
Okay.
also I want it.
Yeah. I will share the notes every day.
Okay,
Yesterday,
sir.
just a few things we have discussed, not many things. So that's why I did not share. But now we
Okay, sir.
have some uh, content created. So now I will share the notes every day after the class. Okay.
Yes, sir.
So tomorrow, Sunday only, the class time is 9 to 10 in the morning. Okay.
Yes, sir.
Right now. Sunday it is 9 to 10 morning.
Yes, sir. Yes, sir.
Remaining day 8 to 9.
Yes, sir.
Okay, so I will share the notes with you. Just give me few minutes. Okay, and we will start with the concept of what mathematical form of electric field. How do we calculate that? Okay, due to a charge particle, what is going to be the electric field? Okay, due to combination of charge, how much will be the field? So these things we are going to discuss tomorrow morning. Okay.
Okay, sir.
Right, every one of you, I hope you are getting what we are discussing here.
Yes,
Yes,
sir.
sir.
Please tell me, all of you are getting what we are
Yes, sir.
discussing?
Yes, sir.
Right. And as well as I will share the week wise plan also. Okay. Just let me write
Okay,
it in
sir.
little bit detail, and then we will share with you in the group that week wise plan. Three
Yes, sir.
classes in mechanics, three classes in this electromagnetism we have. So what we are going to cover it in the week wise. So that planner also I will share with you. Just give me some time, okay? Na? I have the regular classes also, so that's why I will prepare it and I will share with you.
Okay, sir.
Right? Actually, I hope everyone is getting and will start solving the questions. Okay. So take care, everyone. Good night, and let's see you tomorrow morning.
Right, sir. Thank you, sir.
Thank you so much.